and uses this as a training course in order to move not only the government here in Egypt, but also businesses as well, about how to build a cloud infrastructure so that companies can save money and spend less time managing their information. So that was my preparation in 2011. In 2013, I had to prepare myself again to come speak to you. And what's the topic this year? Well, according to the Harvard Business Review, the topic is data science. And when we talk about the sexiest job of the current decade, we're talking about how attractive you would be to a company that needs data scientists. A data scientist is somebody that understands how to analyze massive amounts of information. And again, it's a combination of software engineering, mathematical statistics, and the art of persuasion. How do you visualize massive amounts of information to convince people inside a company to make a decision? So the good news is, before I came to Egypt this year, I took my company's course on big data. And this may be a little bit hard to read, but the course basically covers, first of all, an introduction to big data. What is big data? And what I learned is big data is about volume, high volumes of data, velocity, massive amounts of data coming very quickly into a customer's data center, and variety, a variety of different data sources. I also learned about the life cycle. How do you run a data science project inside a company that allows a company to innovate and add value? So this is one of the courses, again, when talking about my career, in order to challenge myself, I'm always learning about the latest trends. I'm always learning about the newest technologies. And these technologies in the high-tech industry are cloud computing, big data and analytics, and the topic of security and trust. So I want to give you an example of a big data project that I did inside of EMC. You saw during the introduction that my title is Strategy and Innovation. Innovation inside EMC is the most important thing in our company. How do we come up with new ideas that customers are interested in buying from us? Well, you heard Sharif mention earlier that EMC is a company with over 55,000 employees. And my job is to track the innovation activities of all of these employees and to help gather ideas from them, gather research from them. So how am I going to do that job? How am I going to keep track of all the innovation activity around EMC? Am I going to pick up the phone and call Egypt and ask them what they're doing, and then call China and ask them what they're doing, and then call Russia and ask them what they're doing, and Brazil, and Ireland, and all the employees in the United States? It's impossible, right? This is a big data problem. And so what I learned is I needed to follow this approach. I need to follow these steps to gather data instead of talking to people individually. So here's an example of what I do as part of my job. Talk to the people in the United States and I ask them, send me a description every day of what you're doing in the field of innovation. Could be university research, could be publishing a paper, could be submitting ideas, could be going to a conference. Talk to my coworkers in Brazil, talk to my coworkers in Africa, the Middle East, Europe, China, India, and they contribute massive amounts of information into a database. And the next part of the life cycle is to run mathematical models and analyze all of this information about innovation activities. And I'd like to share with you one result. So this is a big data analysis of innovation activity around the globe at EMC. Every dot on this map right here represents an EMC employee who has an idea and has submitted that idea with at least one other person. And the larger the circle is, the more ideas they've submitted. And if the color of the circle is red, that means that their idea was chosen as one of the best ideas in the company. So when I look at this big data visualization, I can see a lot of red. I can see a lot of good ideas, which means I can encourage my coworkers. If you have an idea, it's to your benefit to submit that idea with another person. And I can take this map and I can dive in deeper analytics on clusters and find inventors that work well together and begin to work with these inventors more often. And I can identify who are the best innovators in EMC. And this is happening because I'm using big data analytics. This is the field which really adds value to EMC. So if you remember my chart that shows lowering operational costs and increasing revenue, this is increasing revenue for my corporation. I'm doing big data analytics. I'm finding great new ideas for my company, and then these ideas can be used to generate new products and services that raise revenue for EMC. I also want to talk to you a little bit about my latest research interest. One of the things I'm doing at EMC all the time, in addition to doing studies of EMC's new curriculum, is I'm interested in doing research on my own, doing research with my coworkers, and doing research with universities. And one of the hot research topics today is something called software-defined data centers. At the bottom of the screen, you can see hardware devices, networks, storage, servers, security devices. All of these devices have a lot of intelligence inside of them. And when you run a data center, oftentimes, if you want to change these devices, a human being or a person needs to walk up to them and change the configuration. And this is slow, and this can cause a lot of errors if they make a mistake. So with software-defined data centers, the concept is take the intelligence inside these devices and move it up into a software layer. And then from the software layer, you can very quickly control the entire data center. And you can very quickly write algorithms that sit on top of the data center and respond to attacks, or respond to failures, or respond to performance problems. And this is one of the areas that I'm interested in doing further research. And now that Shams University has built a cloud of their own, they can also participate in software-defined data center research. So software-defined data center is really the ultimate cloud computing environment. We have standardized hardware, and we have very intelligent software that allows us to quickly provision the systems. So this is my last slide. My advice to you, to be a rock star in the IT industry, I recommend that you follow the same approach that I've used in my career. Always learn the latest technologies. For example, cloud architect, virtualized data center architect, data scientist. You have a possibility with EMC to do joint graduation projects, where we take people from EMC Squared who are technologists, and they'll work with you. And we're already doing that for several projects here at Ein Shams. Get yourself familiar with the EMC lab that we built here at Ein Shams. Study the storage system. Study the VMware software that's on the servers. And if you are interested in pursuing specific graduate research with EMC Squared, write a proposal and submit it to us. I review every research proposal that comes in EMC, and would love to see some exciting new research opportunities coming from you. In closing, be happy to connect with you. You can follow me on Twitter, Steve Todd. You can follow my blog, where I write about innovation and I write about the high-tech industry. And finally, you can connect with me on LinkedIn and be happy to build a further relationship with the students and faculty here at Ein Shams. Thank you very much, and I have time for questions if there are any. Yes, in the back. So I couldn't quite hear you, but I think your question was, if there's an attack in a data center, yes, does the response involve shutting down the data center until everything is fixed? Yes. That's not a recommended approach, right? There's some studies in the industry that says for every minute that your data center is offline, you could be losing millions of dollars in revenue. So the recommended approach is to keep your data center online. And here's where a software-defined data center becomes very important. Imagine if a virus or attack comes into your data center and you reduce the dwell time and you discover the virus quickly. Instead of sending a person to reconfigure the data center, if you can call a software API and move the application to a sandbox or an isolated area, that prevents the threat from growing and allows you to analyze that much more quickly. So the answer to the question is no. You really want to make your data center stay up 100% of the time. And the strategy is not to bring the data center down and address the problem. Other questions? That was a good question. Can anybody ask a better question than that? It's a good one. Okay, yes, we have a question here.
Yes, I was asking you about the research opportunities at VetLab, and I want to share us about research opportunities in the creative lab. The research opportunities.
Right. So the question is, we have a lab at Ein Shams, and it's a small cloud, it's a mini cloud. And the question is, how do we do research on a cloud? So the first part of my answer is, the main goal of the mini cloud, the very first goal, is for students to take a course on cloud computing and then be able to actually put their hands on and use a real cloud so that their learning is more complete. Does that make sense? Right? You're just not studying the book, you're studying the concepts from the course, and then you have a lab where you can actually go and use the technology. But can we do research on the cloud? The answer is yes. So first of all, you can write new applications and run them in that cloud environment to do your research. But as I mentioned, there's 5 characteristics of cloud. For example, measured service. How do you keep track of the service used by an application? How much server is being used? How much network is being used? How much storage is being used? How do you keep track of all that for each application? These are areas where there's very few products, there's very few technologies that can solve them. So this is just one area. Study those 5 areas of cloud computing and work with EMC on identifying what some of the gaps are. What questions are still not answered. Because cloud computing is at the very early stages. Other questions? We have another question in the back from the student.
What's different with the VMX data centers? Okay, what the difference between VMX data centers and other data centers and servers from other companies?
So the question is, what's different between, for example, VNX or using the VMAX in the data center versus other companies? So the answer is, if you take a product like VMAX, VMAX has been in existence since 1990. And during the course of time, it's become one of the most trusted, stable storage systems that you can buy. Right? So we have a lot of experience not only in making sure that the system does not fail, but also making sure that the system is fast. So typically, the benefits of EMC storage products are reliability and speed. Question in the front?
My question may be a silly question because a lot of my students ask me what does EMC stand for and why square.
The question is, what does EMC stand for and why square? So it's not a silly question, it's actually a bit mysterious. E stands for Egan, M stands for Marino, and those are two of the founders of EMC. And I don't know the name of the third person, but I believe the third person left the company before it started, or maybe there was 2 people who had the name begin with C for EMC squared. Okay. So it's basically the initials of the founders.
What do EMC expect from the lab?
So the question is, what does EMC expect from the lab in Egypt? I think one of the main things that we're expecting is one of the main things that we're expecting from the lab in Egypt is that when you graduate, your knowledge is advanced. And when you join EMC, you can quickly contribute. So there's a hiring aspect. We want students to not only be good computer scientists and good engineers, but we want them to be educated on topics such as cloud and big data, right? So that's one goal. The second goal is for once the faculty and the students have an advanced knowledge of cloud and big data, they can focus on research problems that are specific to Egypt. What are some of the cloud and big data problems that the companies inside Egypt and in the Middle East are having. And you can solve them only here, because we may not have those problems in the United States, or we may not have the same problems. So we're hoping that the students and the faculty can come up with innovative solutions to Egyptian problems, and then those solutions can be transferred to EMC. We can build new solutions that are useful in the Middle East, and perhaps also sell those solutions around the world. Does that make sense?
What is the strategy you are building on to have these innovations or to solve these problems through the Arab region through the coming years? What will you do to make the students look for these problems to solve?
Well, we'll basically have people inside EMC working closely with the faculty. And the faculty will be identifying opportunities and writing proposals. This is a problem that we'd like to solve. And the reason that they like to work with EMC Squared is we have a lot of experts in cloud, big data, and security all around the world. And if a proposal comes from Egypt to me, because I made all the proposals, I can then begin to match the expertise inside EMC that assists the researchers. So it's really a proposal project that we work closely with the faculty, and the faculty identifies the right students that can help solve that problem jointly with EMC.
So what makes you stand out as a software engineer to work in a company like EMC Squared?
So this is my third visit to my Cairo employees, my coworkers. And what makes them stand out to me is the passion that they have for innovation. So it's, yes, you need skills as a software engineer and a technologist. And when we interview you, we'll make sure you have those skills. But we look for people that love technology and they want to create new solutions. I think one of the statistics that's important at EMC is we have an idea contest every year. And in 2011, I ran the contest globally. And all the employees around the world submitted ideas, and we had a contest and we judged all of them. And last year, Cairo submitted 80 ideas, right? This year, and by the way, none of those ideas were winning ideas. This year, Cairo submitted, I think, 329 ideas out of 2,200 ideas. So more than 10% of the ideas submitted into the contest were created here in Cairo. And there's only 500 employees in a 55,000 person company. 5 of those ideas won an award, and one of them was chosen as the best idea in the company. So the spirit of innovation, of creativity, is really what makes you different as a software engineer. Yes, question?
Can you tell us more about how to use cloud computing in big data related to some complex problems?
I couldn't hear the last part.
Okay. Can you tell us more about how to utilize cloud computing and big data related to software and complex problems?
Right, so how do you use cloud and big data to solve complex problems? Well, my first piece of advice is for you is to take the data scientist course, and you will learn a lot about how to do it. But the chart that I showed you had 6 steps. The first step is identify what problem you're trying to solve. So I was trying to solve the problem of tracking innovation in EMC. And I needed to create some hypotheses. And my hypothesis was If EMC employees communicate their ideas with each other frequently, then innovation inside EMC will accelerate. So that's the first part about how do you solve a complex problem. You create some hypotheses, you create some statements that you try and prove. The second step is to gather data. You need to go to your IT department, and they have a cloud computing environment, and you need to request a large database or a large file system so you can collect all your data. The next step is to explore the data, to begin to look at the data manually and start to understand, is the data complete? Is the data wrong? Are there other pieces of data we need to bring in? That's the third step. And then the fourth step is, what type of mathematical model do I need to run? Do I need to use a clustering algorithm? Do I need to use naive Bayes algorithm? How can I prove my hypothesis? What mathematical algorithm do I need? The next step is to actually run the algorithms, look at the results, and then present the results to somebody important in the company and try and convince them that we need to make changes to the company. So that's the answer to the question. You need to take the complex problem, break it down into some small, provable hypotheses, use a cloud to get your resources quickly, right? If you don't use a cloud, then you have to build it by yourself, right? And then the analytics piece is just choosing the right approach, choosing the right mathematical algorithm so you can analyze the data. Does that make sense? Okay.
Do you think EMC Square will have some kind of cooperation with the Egyptian government in the future? And if yes, do you think EMC Square will work on creating the cloud infrastructure or analyzing the big data or just creating a trust for security system?
Right, so the question is, do I believe there'll be some cooperation with the Egyptian government? And the follow-on question is, do I believe they will use EMC infrastructure to build a cloud environment? Is that your question? So the first part of your question, the answer is yes, right? We've already started collaborating with the Egyptian government, and several years ago, they actually began adopting the curriculum and teaching the curriculum. So the collaboration has already started, and I have visibility to that collaboration, and I've participated. And there's been many more meetings since that time while I'm not here, right? And the discussion is, now that the knowledge of how to build a cloud computing infrastructure has grown inside Egypt, will EMC be the vendor that is used to build the infrastructure? And my answer is, I sure hope so, right? And the reason I think it's a good chance is because we have all the products, right? If you want to put virtualization on your servers, we have VMware. If you need a massive amount of storage, we have VMAX, we have Isilon. If you need to secure the information, we have RSA. So together, we have all the pieces. And we actually have an opportunity. If our customers don't want to build it and put it together themselves, we formed a new company called VCE, VMware, Cisco, and EMC. And it's a cloud in a box. And you buy the box, and you bring it to your site, and it's already wired together. And you turn it on, and very quickly you can use the cloud computing infrastructure. So those are some of the choices that any government or any business or any hospital has as far as what choice do they make and who do they build their cloud from.
My question is about big data. Does big data only focus on large enterprises? Can we apply it on small scale like faculty here?
Yes, so the question is, does big data only matter for large enterprises, or can you do it at small scale? And I think the answer is, you can do analytics at small scale. So information data, it's not big data, right? It may be gigabytes of information. Big data is really about petabytes of information. And usually that means enterprise scale. But still, the concepts that you use in analyzing big data can be learned at a smaller scale and still valuable. So analytics and visualization can be done at any scale, but big data analytics and visualization is typically done at enterprise scale. My friend, this is the third question. He's a great student.
How is the MC squared is trying now to improve the concept of cloud computing? Is it about the hardware capabilities or the software analysis?
So how is EMC squared trying to improve cloud computing? Is it more about the hardware, or is it more about the software? And I think the answer to that question is we need to make improvements in both areas. But in general, we would like the hardware to be standard, and the value is shifting to the software, as I mentioned, software-defined data center. So let me give you an example. If I want to build a private cloud, if I want to build a cloud inside my company, and I have an application storing data, maybe I would like to move that application and move that data to another cloud. Maybe inside my company, or maybe to a company like Google or Amazon, right? That's elasticity. That's migration of my application and my data outside the data center. There's big security problems with that. Is someone going to see my data? Is someone going to steal my data? But it's also difficult to transfer that much data. And it's all about the software, right? It's a software problem. So elasticity is one example. But I see really most of the problems are software related. And that's why software-defined data centers are becoming a much more important research project. Well, you've been great. Thank you for all the questions. Please don't hesitate to contact me or connect with me with social media. Thank you.
Was it good? How was the students? Once they got going? Yeah.